So this is actually one of the applications of solving differential equations. Okay.
Okay.
So our exponential growth, I'll just say exponential functions, they were of this form. Y is equal to a times b raised to x.
Yes.
Okay. And here, what were a and b? A was the initial value. And mostly, mostly you're going to get word problems on this topic. Okay.
Okay.
And in all the word problems, basically they're dealing with a certain period of time, like time is passing and something is growing, maybe population of some bacteria, or something is growing, something is decaying. So usually our independent variable is time.
Yes.
So in most cases you will see instead of x you will have t. So I'll just take t so that you get comfortable with seeing t instead of x.
Yes.
Okay, so a is the initial value. That means when time is 0, that means when we're just starting the observation, what was the value? What was the population of bacteria, let's say? That is represented by a. And
Okay.
b was the growth factor, growth or decay factor. Growth or decay factor. Okay?
Yep.
Okay. Now what we will be dealing with is if we differentiate this equation, in our questions, it will be given to us that the rate of change of or the rate of increase of bacteria's population will be given. So rate of change means what? Again, we come to rate of change.
Like just the derivative?
Yes, the derivative. Okay. So instead of this function, we will be given the differential equation, and the word problems will be mostly like this, that the rate of change is so and so. And we would have to find out the original function. Okay. Now, why we deal with exponential models separately? Because, you will not have to do all the integration and separate the variables, because for exponential models, there is a special formula that you can directly use to find out the original function. We'll see that. So first, first let's differentiate this equation with respect to t. So you'll get dy over dt. A is just a. What will be derivative of b raised to t? Nanda, you remember derivative of b, sorry. So derivative of any number a raised to x was a raised to x times
x prime? Or
times
times
ln a
ln a.
derivative. Okay.
Mm-hmm.
If it is just e raised to x, its derivative is e raised to x.
Just e raised to x.
Yes, but if you have any other number except e, then it is a raised to x times ln a. So
Yes.
here we have b can be anything. So its derivative will be b raised to t times ln b. Okay.
Got it.
Now your dy over dt is, now see, ln b is just a constant. Ln of b was a constant, and ln will be also a constant. Okay. So I'm going to use another variable, let's say k, to represent this constant. Okay.
Okay.
And if you see a times b raised to t, isn't that just y? See, a times b raised to t is y, right?
Yeah.
So this is
Oh,
just
so
y.
you could just substitute like y in for it.
Yes. So this is just equal to k times y, where k is actually ln b, which is a constant.
Yeah.
So this is the differential equation for an exponential function. Dy over dt is equal to k times y. And if you really try to interpret this, what does this tell us? This tells us that the rate of change of y, see, dy over dt is what? Dy over dt is?
Change in y with respect to t?
Yes, rate of change of y. And this ky tells me what? That this rate of change of y is actually increasing at a fixed rate, right? This is a
Yes.
linear function. So this is actually proportional to y. Rate of change of y is proportional to y. So if in any word problem you see that rate of change of something is proportional to that something, then you have to immediately understand that this is the exponential model.
Oh, okay, okay.
Okay, rate of change of y is proportional to y. That will be the exponential model. For example, now we'll do some word problems.
1 second, I just need to write
Oh,
down.
oh yes, sorry.
Okay.
Okay. So let's say now we will have to write a differential equation for some situations. Let's say I am saying the weight of an animal is increasing at a rate proportional to its weight.
Okay.
So the weight of an animal is increasing at a rate. That means they're talking about the rate of increase of the weight.
Of the animal. Okay.
So if you represent weight by a variable w, so its rate of increase can be written by dw over dt, and it is proportional to its weight. So that means you can write k times w. If you remember, you would have done direct and inverse variations also in Algebra 2 or Algebra 1. So when you have direct variation, so you say y is equal to kx. And when you have inverse variation, that is y is equal to k over x.
Oh.
You remember doing this?
No.
This was direct variation, this was inverse variation. Direct variation just means that y is increasing at a linear rate. It is
Okay.
it is proportional to x for different values. Basically, you'll get a linear graph for different values of k. So that's your differential equation.
Okay.
Okay. We will also learn how to solve these differential equations. Okay. Now, can you try to write the differential equation for this situation? So a bacteria population is shrinking at a rate proportional to its population size.
So shrinking at a rate proportional to its population. So to show that it's decreasing or shrinking, would we put a negative in front of it?
No.
Or, okay.
No. Well, a negative constant will be still a constant. So you can just use k. I'll tell you how to deal with shrinking and increasing later.
Okay. So just to set this up, it'd just be like dp over dt.
dp
Yeah.
over dt
Equals kw?
kp.
Oh yeah, kp. Sorry.
Yes, that's your differential equation. Okay. Now, any exponential model will be of this form. Okay. The rate of change of some quantity, that quantity can be anything. It can be weight, it can be population, it can be anything. So the rate of change of that quantity with respect to t will be equal to k times that quantity.
K times quantity. Okay.
Okay, now we will see how solving exponential differential equations. Okay, now you said that for growth, okay, see for growth and decay, that depends on B. You see this factor, growth and decay factor, that depends on B. If your B is greater than 1, in that case, you will have growth. So that means the quantity will increase. If your B is between 0 and 1, that means that quantity is decreasing or shrinking or reducing. That is the case of decay.
Okay.
Okay. Why is that happening? Because see, if I take B is equal to, let's say, 1 over 3. And
I remember this actually.
you remember this, right? Okay.
Yes.
Okay, so now we will see how to solve a differential equation. Now, I told you that any exponential differential equation will be of this form. dy over dt equals to k times y.
Yes.
If you see anywhere this type of equation, well, of course, instead of y, you can have some other variable. But if you see something like this, that means that is exponential model. Okay. Now, first, we will try to find out its solution using a separable differential equation that we did yesterday. We will
Mm-hmm.
try to separate the variables. So dy over y will be equal to k times dt.
KDT. Yep.
So dy, so now we will integrate dy over y, that will give you ln.
Of Y. Yep.
Integrate, k is a constant, and integration of dt will be t, so plus c. Okay, so we can say y is equal to e raised to kt plus c. Okay,
Okay. Just could you explain where the how the dt turned into t? Because I didn't know we would integrate the dt as well.
which one?
You said the
Oh,
integration of k dt turned into kt, right?
oh, okay. So tell me what will be the integration of k dx, and making it easier, what will be the integration of 4 dx?
Integration of 4 dx?
Mm-hmm.
Just 4x.
4x.
Oh, that's why. Okay, that makes sense.
Okay. So instead of 4, we have k, that's a constant, and variable can be anything.
Okay, that's why I got confused. Okay,
Yes.
thank you.
So, and in these problems, mostly you will have t as your independent variable. In most
Okay.
of the exponential models, your independent variable will be t instead of x. That's why I said we feel comfortable with x and y. Okay, so this is just that. So now, Nanda, if you see, I can write this as e raised to kt times e raised to c.
Yes.
Yes, because the exponents get added.
Mm-hmm.
And e raised to c is what? This is actually another constant. This will be a constant, right?
Mm-hmm.
Because e is a constant, raised to c, c is another constant. So this will be a constant.
Okay.
So I will write this new constant by variable c, okay?
Mm-hmm.
E raised to kt. Or if that confuses you, you can use another constant. Let's take a. So your equation becomes y is equal to a times e raised to kt, where a is a constant, k is also a constant. So this is your solution,
Okay.
okay? Where this a that you see, that represents your initial value of y, okay?
Okay.
Okay. Now, in this case, your growth and decay will depend on whether k is positive or negative. If your k is positive,
Mm-hmm.
that means you're dealing with e raised to a positive number, so you'll get growth.
Okay.
Because e is what?
Yeah,
2.7128,
yeah, yeah.
and that is greater than 1. And
Mm-hmm.
that number raised to a positive number, that will be still greater than 1. And if k is negative, that means now 1 over 2.71. So that is between 0 and 1.
Oh,
So that
okay.
will be decay.
Makes sense.
Okay, so we will quickly do some word problems. Now, you know, if you have to find out solution of a exponential differential equation, you don't have to do all these steps. You can
Oh,
directly write your solution using this formula. Okay,
okay. Okay.
let's see how. Okay, so we have a differential equation, dy over dt equals to 6y, and y is equal to 5 when t is equal to 0. Okay, we have to solve this differential equation. Now, you have to realize that this is actually an exponential equation.
Yes.
I mean, this is the solution to this will be exponential.
Mm-hmm.
Okay, if you compare it with the original equation that we had, dy over dt, we took equals to ky.
Yeah.
So the value of k here is 6,
Yep.
right? We want to write the solution. Solution is this: y is equal to a times e raised to kt.
Yeah.
Y is equal to a times e raised to kt.
So
Okay.
y equals, I'm not sure what a is, but
You
a
know what
is,
K
e
is 6.
raised to 16.
Mhm. Right. Now A, if you remember, A was the initial value. A will be initial value.
Oh, okay, and it gives us that. Okay,
Yeah. Initial value means value of y at t is equal to 0. This
right.
is y when t is equal to 0, and that is given 5.
Okay.
That means this is the value of A. So your solution is, you can write it directly, y is equal to 5 e raised to 6t. That's it.
No plus c, right?
No, no plus c. When you have the initial condition, then we don't write plus c.
Got it. Okay, I got it right.
Okay. Okay. One more problem. Now let's take a word problem. Okay. Okay, Nana, quickly try this. Dy over dx is equal to negative 3y, and y is equal to 4 when t is equal to 0. You try this. Meanwhile, I'll just write the next word problem.
Okay. Okay, I got y equals 4 e raised to negative 3x.
Yeah, that's correct.
Okay.
Okay. Next, this is a word problem. An animal weighs 3 pounds at birth and 4 pounds just 3 months later. The weight of the animal is increasing at a rate proportional to its weight. How much will the animal weigh when it is 5 months old?
Mm,
Hmm. So here the most important statement is this, that the weight of the animal is increasing at
yeah.
a rate proportional to its weight.
Yes. So dw over dt
Hmm.
equals kw.
Kw, yeah. That's the differential equation. Now if we want to find out how much will it weigh when it is 5 months old, definitely first we need to solve this equation.
Yes.
Okay. So its solution is given by y is equal to a times e raised to kt, and instead of y we have w because this is weight. The dependent variable is w.
Yes.
Now from the question we need to figure out the values of a and k.
Yes. So at birth, that would be 3. So a is equal to 3.
Yes, a is the initial value,
Mm-hmm.
so a is 3. So we have w is equal to 3 times e raised to kt.
Yes.
Now we want to find out the value of k, and for that you can use this information that it was 4 pounds just 3 months later.
Hmm.
That means the weight of the animal was 4 pounds after 3 months.
Mm-hmm.
So that means they have given w of 3 is equal to 4.
Oh, okay, okay. So
That means
then 4 equals
4
3
equals 3 times e raised to k times 3.
times 3. Okay, okay.
From here, we have to find out the value of k. So first, you can divide by 3. 4 over 3 is equal to e raised to 3k.
Yep.
You'll have to take logarithm on both sides.
Mm-hmm.
And since you
So
have
3k log 4 by 3 equals. Wait, that makes no sense. Never mind.
now ln of 4 over 3 equals ln of e raised to 3k. And ln of e is just 1. 3k comes in the front.
Yes.
So 3k. ln of e will be 1, and k will be 1/3 of ln 4 over 3. You can use your calculator to find out this value,
Mm-hmm.
ln of 4 over 3, and then divide that by 3. So that will give you k as something. It will be 0.0958 something.
Okay.
So that means your equation becomes Wt is equal to 3 times e raised to 0.0958 t.
Okay.
And we have to find out its weight when it is 5 months old. So we just have to put t is equal to 5 in this equation. So 3
Yeah.
times e raised to this number times 5.
Times 5. Okay.
That will give us the answer.
Okay.